In this video, I'm going to show you how to graph an equation. So we've already looked at graphing linear equations, and linear equations are a specific type of equation. So the methods that we used, finding 2 points or finding the point in a slope, only work for linear equations. This method that I'm going to show you works for any type of equation, whether it's a linear equation, a quadratic equation, or any other equation that you come across. So here it says sketch the graph of y equals 5 minus x squared. The first thing we're going to do here is we're going to make a table of values. We're going to pick values of x and we're going to substitute them into the equation and calculate y. So oftentimes when I show people how to do this, I actually like to make a third column in the middle. Okay, where this is y equals 5 minus x squared. The middle column ends up being like our scrap. So I don't really know what values to pick right now. I like to pick some negative values, 0, and some positive values. And as you get more familiar with different equations and different functions, you'll have a better idea of which values to pick or which ones to start with. So I'm going to pick -2, -1, 0, 1, and 2. And hopefully this gives us a good picture of what it is we're looking at. So I'm going to substitute that into the equation, and I'm just going to write the 5 minus x squared right here. Okay? And the equals y part is actually going to go in the right column. Okay, so this becomes 5 minus, substitute -2 in for x. So this becomes 5 minus -2 squared is 4, and 5 minus 4 is 1. So that is the point. Let's add a fourth column here. That is the point -2, that's our x coordinate, comma 1. And let's plot that on the graph. -2, that's left 2, up 1. Okay, let's do the same thing for -1. 5 minus -1 squared. So 5 minus -1 squared is 1. 5 minus 1 is 4. So that's the point -1, comma 4. We don't need a straight line there. So now we have 5 minus, substitute 0 in here. 5 minus 0 squared is 0. So I know this is just going to equal 5. So that's 0, comma 5. Okay, so just so we can follow along, this is -2, 1. This is -1, 4. This is 0, 5. Okay, substitute 1 in. 5 minus 1 squared, that's 5 minus 1, which is 4 again. So that's the point 1, comma 4. And finally, 5 minus 2 squared, which is 5 minus 4, which is 1 again. So that's our point 2, comma 1. Okay, so you can see if we just connect these with a smooth curve, looks something like this. Well, we're going to continue this pattern in either direction. Okay, so it's going to look something like this. So when you're finished, you always want to connect your points with a smooth curve. And of course, there are points in between all of these integer x values, right? And there is a chance, of course, that maybe the graph does like some funky things in here and isn't connected with a smooth curve, but that's not true in this case. Okay, we're familiar with this function, or at least I am familiar with this function. This is just a quadratic equation which has a graph that is shaped like, in this case, a bell. Sometimes it's shaped as a U. Okay, that's called a parabola. So in the end, to make a long story short, anytime you're asked to graph an equation, you can make a table, pick values of x. Okay, you pick the values of x, and then you calculate using the equation your values of y.